Assalamualaikum and hi everyone. So today our group will present our assignment 3. The first question, which of the following is not a type of processor scheduling? So the answer is priority scheduling. Second question, what is the main goal of short-term scheduling? So the answer is A, deciding which process to execute next from the ready queue.
For the third question, so which scheduling algorithm is also known as FIFO? So the answer is B, first come first serve, FCFS.
Moving on to the fill in the blanks question. For the first one, the scheduling policy that selects the process with the shortest remaining execution time is called shortest remaining time. The second question, in a round-robin scheduling algorithm, the key parameter that determines how long a process runs before being preempted is called the time quantum.
A scheduling policy that ensures that longer processes do not starve by increasing their priority over time is called aging.
SRRN, the metric is the select process based on highest response ratio. And the feedback is use dynamic priority adjustment.
The FCFS, first come first serve. The characteristic is process execute in the order of arrival. Round robin, the characteristic is uses a time quantum for preemptive scheduling.
So for the SPN is the short form of shortest process next. So by knowing its name, SPN will select the process with the shortest service time.
So next we move on to subjective questions. So question 1, in uniprocessor scheduling, the execution of each scheduling policy is based on their selection function and decision mode. So A, what does it mean by selection function? The selection function is the criteria or method used to choose which process from the ready queue should be executed next by the CPU. Or in simple words, it is how the scheduler picks the next process to run. So next.
So what does decision mode mean, and explain two types of decision mode? So the decision mode refers to the point in time when the scheduler makes its decision to switch processes. And two types of decision mode are: first, non-preemptive or cooperative. So this means the scheduler waits until the running process voluntarily releases the CPU. The second decision mode is preemptive, which means the scheduler can interrupt and switch out the current process. For example, when a higher priority process arrives.
The C section, explain about the selection mode and decision mode for each of these scheduling policy below. So for first come first serve is the simplest scheduling policy. For selection mode, it will select the process based on arrival time, which means that when the scheduler needs to pick the next process to run, the process that has been waiting the longest in the ready queue will be chosen first. And for decision mode, it is non-preemptive, which means that once a process is given the CPU for it to run, it will run until it is finished without being interrupted by the scheduler.
So now, two Romans. The processor tu akan checking lah, frequently checking if the another available process yang ready, yang dia punya burst time tu more shorter than the current process, dia akan interrupt will be happen lah, which is the preempt. The preempt tu, the preempt action will be occur lah. Dia akan interrupt, dia akan interrupt and dia akan run the process yang execution time tu shorter than the current process.
Maksudnya selection, the process will be
So decision is non-preemptive lah.
betul.
Okay, sorry.
The shortest remaining time is selection mode. The decision mode is
For the highest respiration next, the selection mode is process are selected based on the ratio. So the formula for ratio is ratio equal to waiting time plus service time, and then divide by service time. So the process with the highest ratio get selected first. Okay, then for decision mode, the highest respiration next is non-preemptive. Once a process start executing, it will run to completion. The next process is only selected after the current one finishes.
So for round robin, the selection mode is time quantum. What is time quantum? Time quantum is each process will be given fixed time to execute. So the decision mode for round robin is preemptive. At first, process will complete its burst time within time quantum. After reaching its time quantum, it will move back to ready queue, and the next process will be run next.
So the last question is feedback. Feedback selection mode chooses process from the highest priority non-empty queue. And if a process uses too much CPU time, it is moved to a lower priority queue. So CPU-bound processes get less immediate attention than IO-bound ones. And then decision mode in feedback scheduling policy. When scheduler makes decisions, feedback scheduling usually uses a preemptive decision mode. The scheduler may interrupt a running process when a newer or higher priority process arrives.
So next for algorithm question number 1, A, first come, first serve. Okay, so given process A, B, C, D, arrival time 0135, service time 5486. So how to calculate the first come, first serve? First, we need to draw the Gantt chart, which is include time and process. So for process A, the Gantt chart, we calculate from arrival time 0 until the service time, which is 5. So for the process B, we plus the 5 with 4, and then we got 9. So same goes with process C, 9, we plus with 8, and then we got 9 until 17. And then for process D, same step also, we plus the 17 with 6, and then we got 23. Okay. Next, for the step 2, we must calculate the waiting time. So the formula is start time minus arrival time. So we must draw the table. They'll start with the process, arrival, service, start, finish, and waiting time. So for arrival, we just copy from the table given, same with service. And for start, we just copy from the left-hand side from the Gantt chart, which is 0, 5, 9, and 17. And same with finish also, we just copy from the Gantt chart we just drawn. So process A, 5, process B, 9, process C, 17, and process D is 23. So next, we must calculate the waiting time. So we must minus the start time with arrival time. So for process A, 0 minus 0 is 0. Process B, 5 minus 1 is 4. Process C, 9 minus 3 is 6. And process D, 17 minus 5, we got 12. So step number 3, we must calculate the average waiting time. So how to calculate? We just plus all the numbers in process A, B, and C, and D. We got 0 plus 4 plus 6 plus 12, and we divide by 4. And the average time we got is 5.5. And so the final answer is we just follow the Gantt chart. A, start with process A, and then B, C, and D. Process A, process B, process C, process D. And answer number 2 is the average waiting time is 5.5 units, which is we just calculate in step number 2.
Algorithm which is known as shortest process next. So hence the name. We will be determining which process runs first by looking at the duration of service time. So we have 4 processes A, B, C, and D. The initial table only provided us with arrival and service. The start and waiting column I added myself. So for process A, B, C, and D, we shall look at the arrival time. So the first process that arrived first was A. So A will be executed first, straight away. So A took 5 microseconds to execute and finish. So during the completion of process A, we have 3 more processes, and how should we determine which process should run next? So we will look at the shortest service time for each process. So for B, we have 4, for C, we have 8, and for D, we have 6. So the shortest process will be B. So B will be the next process that will run after A. So the process B will take 4 microseconds to finish, and then we will then execute the next shortest process, which is D, which takes 6 microseconds to execute. And then finally, we will execute the last process, which is C. It will take 8 microseconds. So for us to get the start time, you just look at the which microsecond the process began executing, which is for B it's 6, for C it's the 10th microsecond, and for D it's the 10th microsecond, apologies, and for C it's the 16th one. So for the waiting time, just subtract the start time with the arrival time, and we will get the waiting time for each microsecond for each process. So to get the average time or average execution time for all of the processes, we will just add each process's waiting key, subtract them by 4, because there is 4 processes present.
So now we move to shortest remaining time. So first thing first, we have to do the scheduling diagram. So dia punya arrival time for A is kat sini lah. And then for B, kat sini. And then C, dekat ini 3. We can see that for the B process is has shorter process time compared than A. So what the system does is it interrupts the A process once the B arrival time is reached the system. Then what it done is it will be execute until reach to the second micro. And then the process will run the previous process again. So the diagram will be like this for the two process on for the first initial process, two process. Okay, and then proceed with the remaining process. Okay, for the C, burst time is 8. Macam ni total dia 4. Kalau yang ni total dia 5. So dia akan fokus on more the shorter one. So dia interrupt tu berlaku kat sini.
So now we want to search for waiting time. So the formula of waiting time is total of start execution minus arrival time. So for A, it arrived at 0, right? It arrived at 0. So we put arrival time 0 and it start its execution at 0.2. So the waiting time for first iteration is 0. And then we have the second iteration here. So after it complete the first iteration at here, it go to the second iteration, which is it arrived at second iteration at 1. And the waiting for execution is it wait for the execution at t equal to 5. For B, it arrived at 1. It start execution at 1 and it arrived at 1. So the waiting time is 0. And then C, C arrived at 3. It start execution at 9. D, it arrived at 5 and it start execution at 17. The average the number of process.
Now, I will explain about the algo for the higher respiration nets scheduling using this. Step 1 is time is 0. Only the problem in the ready queue. So the respiration is A equals to 0 plus 5 divide the 5 equals to 1.0. So we choose the select process is A and the execution time is 0 to 5. So the step 2 is time is 5. So basically time is 5. So process B, C, and D have arrived and ready to the queue. So when they ready to the queue, we calculate the response ratio for each process. For the response process is B 4 plus 4 divide equal to 8 divide 4 have a 2.0. So C plus 8 divide the 8 you get the 1.25. D 0 plus 6 divide to 6 get the 1.0. So with the highest respiration, we select the B. So the execution is 5:29. So 3. C, the time is 9. So when the time is 9, the ready queue is C and D. So when the ready queue C and D, we calculate the C and D, the respiration. So for the C, when the time C is 6. So the 6 is 6 plus 8 get the 40 and divide the 8 get the 1.75. Under the D equal to 4 plus 6 get 10 and 10 divide the 6 get the 1.67. So the higher respiration is the C. So the execution time is 9 until the 70. So for the 4 is 70. 70 the time for the ready and the ready queue is D only D. So we calculate the D is 12 plus 6 equal to 18 and 18 divide the 6 get the 3.0. So when they get 3.0, we select the D for the process respiration and execution time is 70 equal until 23. So actually average time is we select the time of the executive time and divide the total process. How many process we need to the done the respiration. So total process is 4. So average time is calculate the time 0 plus 4 plus 6 and plus 12. So when get the plus 12 is get the 22. So 22 divide the 4, get the 4.4 units.
So I'm gonna explain about round robin. So for the question 1, E, the time quantum given is 2. So we see at this table and we go through for the process A. So process A arrival time is 0 and the service time is 5. So at the time 0 until 2, the A arrive and then A runs. So the service time is 5 and minus 2 and the remaining for the service time is 3. So B arrive at time 1 and B ready to queue. And after process A completed at time 0 until 2, process A queue after process B. So after that, at time 2 until 4, B runs and service time of B is 4. So B minus 2 because of the time quantum is 2. So 4 minus 2, so we get 2. So the remaining for the B is 2. So C arrives at time 3. So B is Q after A, and after B completed at time 2 until 4, B Q after C. So then at time 4 until 6, A running, and the remaining for A is 1, and then at time and D arrive at time 5, and D Q after process C, and then after A is completed running at time 4 until 6, AQ behind D. And then at time 6 to 8, B running, and then remaining is 0, B is done. So the ready queue just C, D, and A. So at time 8 to 10, C is running. So the remaining for the C is 6 and C queue after A, so DAC. And then time 0 until 12, D continue to run, and the remaining for remaining for D is 4, and then D is queue behind the C, and time 12 to 14, A is run, and remaining for A is 0, and then A is finishes with 1 unit left. So the ready queue for the next queue is C and D. So at time 4 until 16, C runs, and the remaining for C is 4, and C is queue behind the D, and time 16 to 18, D run, and remaining for D is 2, and then D is queue behind C, and time 18 to 20, C run, and remaining is 2, and the ready queue is DC, and then at time 20 until 22, D run, and the remaining is 0. So D is done, and the ready queue just C. So at time 20 until 24, C runs, and C also complete. So all you get time is 24. So the conclusion is the completion, process A at time 14, process B at time 8, process C at time 24, process D at time 22. So we're gonna calculate for the turnaround. So 14 minus the arrival, the completion minus the arrival. So 14 minus 0, so we get 14. 8 minus 1, we get 7. 24 minus 3, we got 21. And 22 minus 5, we get 17. So that's for the turnaround. And the waiting, uh, the completion is minus turnaround. So 14, no, my bad. So for the turnaround, minus burst. Right. For the waiting, turnaround minus burst. So 14 we get, we minus 5, the burst. So the waiting for A, we got 9. So same like before. For the process B, turnaround minus burst. So 7 minus 4, we got 3. 21 minus 8, we got 30. And 70 minus 6, we got 11. So this is waiting time. So we're gonna find the average waiting time. So we add, we sum all of this from A to C, from A to D. So 9 plus 3 plus 30 and plus 11. So we get and divide by 4. So we got the average waiting time.
Last question, which is true for the feedback. A arrived at 1 at 0. B arrived at 1. C arrived at 3. And D arrived at the RQ1, the time quantum allocated is 2, while RQ2, the time allocated is 1. And the RQ3 time allocated is 1. So the first process that arrived is A. So A, we must go for the 2 time. 1 and but before the A complete, B has arrived at T equal to 1. So we must put B at the RQ1. And after the A complete, we can move to the next process, which is B. And B, sorry, for after A has complete its RQ1, which is 2 time quantum, so move the A to the RQ2. So A, its balance is 5 minus 2, which is 3. So the 3 process we need to form with this. And for the B, for the B, we have to run for 2 seconds. And after the B complete, before B complete, C arrive. So we put C here. And then C, we must do 8. 8 first time. So here B have complete is 2 first time, which is after the B has complete, we shall move the B to the RQ2, which is the balance of this time is 2. And then we can look here. So for C is C for the RQ1, it must complete 2 burst time, which is we complete here. And before C complete, the D has arrived at D equal to 5. So we have marked the arrival of D at RQ1. D, the first time, the service time is 6. And here the C has complete its first quantum, which is the complete. We shall move it to the lower priority queue, which is the remaining service time is 6. And then we shall move D. To D is D will perform 2 service time here, and it's complete. So we move D to the lower level of queue. With D, the balance is 4, and then we shall go back to the A, but at RQ2, the time quantum is only 1, so we shall run only for the 1 second. So for A, if we move 1 here, and then we move A to the lower level of the queue. So the remaining of A is 2, and then B, the 1 quantum, will be marked done, and it is moved to the lower priority queue. And C, of 1, and it shall move to the lower level of queue. The remaining service of C is 5, and we shall run for the process and complete for RQ move the D to the lower level priority. So we shall move back to the A. It have 2 remaining service, and the RQ3 time quantum is only 1 by RQ2. Then we can make as usual. A run for 1 second. So the remaining of A is 1. Then B 1 second. And after at T equal to 14, B has complete. So it will not go back to the queue. And then C, we have 5 more, and we complete its 1 time quantum. It shall move to the it will move back to the queue. So C, the remaining is 4, and then D is 3, D we run for 1 second, and is the remaining is then we move back to A. A, it have 1 quantum, it have 1 remaining service time. So here A will be complete, and it will not move back to the. So after that, C we have remaining 4, and it will run at 1 second here. So the C will be moved back to the Q3 with remaining of 3 service time. Then B run for 1 second, and the remaining is 1. So we shall move back to C. C. C run for 1 second. And the remaining is then D run for 1 second, and the remaining is D run for 1 second, and the D is complete and it will not move to the Q back. So we shall move to the C. C we have 2 remaining service time, and here we shall complete only 1 term, and then the remaining is 1. And then we shall complete the process C process, and all the service are complete. So the average time, the formula of average time is what is total of start execution minus arrival. Jadi untuk A shall kita tengok dekat sini. And A ni arrive at 0, and it run at 0, 2. And then this is not complete yet because we have the iteration of the execution of it. So we have to pass start of execution here. Okay. Minus rival at, because when the A complete its RQ1, it will move directly to the RQ2. So if A complete at T equal to 2, it will move to the RQ2 at T equal to 2 also. So the arrival is 2, and plus start of execution T equal to 12, and arrival T equal to 9. So plus 12 minus 9 plus 16 minus 13. 16 minus. This is for A. And then for B, then also look at B. B, it arrived at T equal to 1, and it start execution at T equal to 2. So 2 minus 1 plus 1 second iteration. It start execution at T equal to 9, and then it arrived at T equal to 12. So 9 minus 4. 9 minus 4. Plus D start execution at 13, and then it arrived at T equal to 10. So 15 minus 9. Then after 13, there are no remaining service time. So it have to complete here 13. So for C it arrived at T equal to 3, and it start execution at 4. So 4 minus 3 plus start execution at T equal to 10, then it arrived at T equal to 6, and minus 6. Plus C start next execution at T equal to 14, and it arrived at T equal to 11. So 14 minus 11, and then the next execution start at 17, and it arrived at T equal to 15. So 17 minus 15, and the execution start at 19, and it arrived at 18. So 19 minus 18, and the last, not last, the second last execution of C, which is it start execution at 21, and it arrived at T equal to 20. So plus 21 minus 20, 21 minus 20 plus because here we have two iterations. We have two times running process. It has 2 times start execution. So here, after C have complete at C equal to at T equal to 22, it will directly execute at this. So start at 22, and it also arrive at 22. Waiting time is 0. So for D, it arrived at T equal to 5, and then it start execution at T equal to 6. So 6 minus 5. Thus, the next execution start at T equal to 11, and it arrived at T equal to 8. So 11 minus 8. Thus, the next execution start at T equal to 15, and it arrived at T equal to 12. So 15 minus 12. 15 minus. So plus the next execution of D start at T equal to 18, and it arrived at T equal to 16. So 18 minus 16. And then the last execution of D start at T equal to 20, and it arrived at 19. So 20 minus 19. So we have to sum up all the process waiting time. So for E, total waiting time is 12. So for B, the total of waiting time is 9. So for C, the waiting time for C is 12. And first process, which is D, it waits for 11. So the average waiting, sorry, this is waiting time. And this is average waiting time for million. Average waiting time million. We have to sum up all this. 12 plus 9 plus every over the number of process, which is 4. We sum up 9 plus 12 plus 11. So the average waiting time is 11 meters per second. So this is the average waiting time, and this is diagram scheduling.
So that's all from us, Group 10. Thank you.